So you really have to look at what is the challenge. If you don't have coccidiosis problems, great, because your choices are much greater, because there's less chemistry that can inactivate the coccidiosis. So let's have a look at how we get the list. As I mentioned, the vaccine. Just put the vaccine, whatever that virus is. The next is the diagnostics. So this is the main job of the veterinarian, of course, in the farm. What was the challenge in the last 2 flocks? Not the last flock, the last 2 flocks, because you could have a trend of challenge. If you have a trend of challenge, what it means, potentially there's a vertical transmission, let's hope not, or we didn't inactivate the pathogen between this crop and the next crop, because you got the same thing again. So it wasn't, did the worker do the job? Yes. We did the cleaning, we did the swabs, the bacterial swabs, 80% cleaning efficacy, great. Disinfected, still the challenge. So did we use the right chemistry? Did we make the right investment? This is the diagnostics. Of course, you have some very highly populated areas where your neighbor may not be quite as good at biosecurity as you are. And you can get some bioaerosols and some challenge. And of course, you have the seasonal. Seasonal, not just about summer-winter, but summer-winter really is a big factor. When I've been in Pakistan before, you have more respiratory challenge in 2 times of the year. And this is normally around climatic challenges. So it's really forming the list. With that list, working with the DMG team, with ourselves, designing a protocol for that cycle, for that pathogen. And it won't be the same for broilers, layers, and breeders. You will have differences. We know that...
the previous slide. इसमें ज़रा इसको देख कर बताइएगा कि कोई और ऐसा फैक्टर है जो हमें अपना पैथोजन कंट्रोल प्रोग्राम स्पेसिफिकली फॉर डिसइंफेक्शन बायोसिक्योरिटी जिस फैक्टर को आप समझते हैं हमें उसको भी कंसीडर करना चाहिए. आपकी एक्सपर्ट ओपिनियन इस पे क्या है? मतलब उसने सारे लिस्ट लिए हैं, कोई फैक्टर उसने स्किप किया है कि जो उसने यहाँ पे मेंशन नहीं किया. मतलब वो कह रहा है अपनी वैक्सीनेशन देखे, पहले क्या चैलेंज आया उसको देखे, आपके नेबर में क्या चल रहा है उसको आप देखेंगे, सीजनल रिस्क जो है उसको आप जो है वो फॉरवर्ड पार करेंगे. कोई ऐसी चीज जो इसने स्किप की हो
ठीक है.
ठीक है.
Yep. Then we have, this is just a list of viruses for an example. I started with adenovirus because in the UK these days we're having quite a big challenge with this, but reoviruses, Gumboro, these are all non-envelope virus to here. Then we have envelope virus. What is very specific, the non-envelope virus have a much more stable pH. So you really need to have an acid or an alkaline to inactivate those quickly. You can activate them with neutral pH chemistries like quaternaries, glutaraldehydes, but it takes a longer time. The thing about adenovirus is survives 35 to 40 days on plastic. So what do you have that's plastic? Feeder pan, plastic. Waterline, plastic. So when you're disinfecting these areas, they are what we would say are non-porous inside the foam. So you spray, the water drops off, the solution drops off. Do you have enough contact time for that inactivation of the adenovirus? You will for the envelope virus. So we're always thinking about avian influenza, Newcastle, infectious bronchitis. True, they are very challenging. Even in the UK, DEFRA tests only against those pathogen in virus. Yes, they're damaging, but they are easy to inactivate because they have a very short stability. 6 to 6.5 pH means they are easy to inactivate. We can easily challenge those, but not necessarily the same with the non-envelope. So it's very important we look at which is the challenge. We think about mycoplasma. These are just some simple studies. I always put the references, but how long they survive outside the host. So mycoplasma is particularly difficult for Quaternion pneumonium to overcome. So again, we have to look at the pathogen to understand which chemistry. I mentioned Quaternion pneumonium there twice because it's not good against, not as good against, bless you, non-envelope virus or mycoplasma. But it's very good against fungus and gram-positive bacteria. So Enterococcus, Staphylococcus. So you really have to understand what this list is. The temperature I don't think matters as much as it does in other countries, but I took the different areas. Still, in Lahore, November to March, morning and evening is cool. So if you're using glutaraldehyde and quaternionium compound, don't use it early morning or evening, middle of the day. Make your disinfection middle of the day when at least you have the heat. Because when we look at this slide, glutaraldehyde needs 20 degrees plus. Quaternionium needs 20 degrees plus to give the full effect. So I'm going to come back to it, so don't worry. If I go backwards, I'll come back. So really think about the time of disinfection. The chemistry works, no problem. But do it at the right time of day, just as a tip. So I leave it on here so you can do your photo if you want to. It's fine. And these are quite accurate studies. This is what we generally know about chemistry. When I'm in Islamabad on Friday, it's worse for them. They have a longer, cooler period, even in the daytime sometimes. In the winter, it doesn't get very warm. So we have to think about perhaps phenolic chemistries in those times. They also have to think about residual chemistry. Residual chemistry means we spray a non-porous surface, doesn't matter, porous, semi-porous, so concrete, wood. A lot of concretes. These are proven to be, this is quaternionium, the chemistry stays in the pores of this concrete. Whenever there is moisture, you have a lot of humidity, there is bacteriostatic action. This is good. So this means you have long acting. So this is one of the reasons why we really think about two types of chemistry when we're recommending in our programs, because we want to have residual chemistry. Residual chemistry will be glutaraldehyde, quaternionium, phenol, iodine. These are all residual chemistries. Carry on acting in a semi-porous or porous surface. Non-residual, as the neogen peroxide super, you apply, it dries, it's gone. In Europe, they love it because that means it's biodegradable. So we can use it, going to the question before, we can use that in organic farms because there is no traceability at all of that chemistry. What is good, it's very fast. So we can use it to have a knockdown of the virus, let the surface dry, and then use a second chemistry. And that is the reason why. So when you think about, if you think about using more than one chemistry, always use non-residual first, residual second. Otherwise, there's a compatibility issue. Shukran. For us, for DMG, we have the full range of chemistries available, except hydrogen peroxide. We don't export hydrogen peroxide for specific reasons. To be honest, it's volatile chemistry, and it can be used in a way that it shouldn't be used for. And so Neogen doesn't use it as an export chemistry. You can buy it locally, I think. But we have iodines, we have glutaraldehyde quaternary, so Viraquat 300. Nice, it's best in class, actually. It's the top performing glutaraldehyde quaternionium. Then we have quaternionium glutaraldehyde, quite different. This one would be for hatchery, for example. We don't want too much glutaraldehyde in the hatchery, so it's only 7%, and you use 1 to 250, so very low glutaraldehyde content, so that the worker in the hatchery doesn't get exposed, but 4 different quaternioniums to overcome aspergillus, fungus, and the bacteria. And then, of course, we have the black extreme, and DMG now have the new farm fluid just coming through as well. And, of course, neogen peroxide super. So when we're looking at a program, it'll really be about which of these is best for which pathogen, not, which is the best to sell. It's for us, which is the best looking at the pathogen. Whenever you're using more than one chemistry, as I mentioned, always use non-residual before residual. That's all that slide does in a long way of saying it, because quaternioniums are cationic surfactant. In neogen peroxide super, we have anionic surfactant. These will interact. they will reduce your investment. So always non-residual before residual. Okay, some basics. As I mentioned before, you're all a very experienced team, one learning, everybody else very experienced. So you know about the barrier controls. One thing we've been doing quite a lot more recently is we use a lot of agricultural lime on the walkways to change the pH of the environment. It's not expensive, especially if you've got wild birds coming through over biosecurity fencing. They can defecate on the ground. The virus survives, can be walked. Even if you have a good foot dip, could be walked into the house. So we use a lot of agricultural lime, just basically changing the environment. Not expensive, not the chemistry we sell, but the chemistry we do recommend. When we're thinking about vehicles, if you have wheel dips, ideally they should be covered. I did see a wheel dip today, open. The only chemistry that works with direct sunlight is phenol chemistry. No other chemistry works in direct sunlight because it degrades with the UV light, except the phenol chemistry. So if you do have this type of a system, cover it. If you have sprays, sprays are okay, but they need to be fast-acting chemistry because this is a non-porous vertical surface. We spray, it runs off. But what exactly are we trying to kill on a vehicle? Normally it's envelope virus, so not too damaging. We can't think about, we're not killing coccidiosis on a vehicle. We're not trying to get non-envelope virus. So it's normally Newcastle, maybe IB, AI. So we can do it. But you need to try and think about using the faster acting chemistries. And especially, as I mentioned here, as I mentioned in the foot dips and in the wheel dips, we're using the robust phenol chemistry. This will last 1-2 days without derogation, but don't forget you might get evaporation, you might need to top up if it's in direct sunlight. But my advice, wherever you can, cover it. The workers, of course, whatever system you have, they're all different. We make sure the worker comes in. One of the good ways that we've found to train the worker to make sure they do the proper shower in, shower out, we explain them we are protecting your family, not the other way around. Because salmonella is zoonotic, coccidiosis could potentially be even zoonotic, protozoa can carry home. There's so many zoonotic challenges inside the farm, so we say to the worker, do this, it protects your family. Then they're more likely to do the job very nicely. And again, outdoor foot dip, robust chemistry, indoor foot dip, neogen peroxide super. Very simple protocols. Cleaning and disinfection. This is the main task. I think everybody here understands the value of cleaning. Is correct? You understand we have to clean before we disinfect.